Now this problem is a little more complicated. So far second derivatives or third derivatives haven't involved all that much, but this one will demand a little bit more simply because it's implicit differentiation, and you'll see why soon. So we do not have the y explicitly defined in terms of x, so we do the usual thing, implicitly differentiate it. So 3y squared would become y cubed. The derivative of y cubed would be 3y squared, also y prime. As always, when you try to differentiate y in terms of x, you need to write it simply as dy dx or y prime. That's all you can do with it. You can't go any further. That xy will have to you have to use the product rule on it. So the derivative of x is 1 multiplied by y plus x, it remains, and the derivative of y is y prime. And this is in brackets so that we don't lose the signs. The derivative of 1 is 0. So this is now 3y squared y prime minus y minus x y prime is equal to 0. So gathering up the y prime terms, 3y squared y prime minus x y prime, this is equal to y. Factor out the y prime, and you'll get 3y squared minus x is equal to y. And then y prime is equal to y over top of 3y squared minus x. Now that's fine, but now to get the second derivative, we're in a bit of a bind because in order to differentiate this, we're going to have to use the quotient rule. Or I suppose you could use the product rule and the chain rule together if you wanted, but I'll stick with the quotient rule. It's set up nice. U is equal to y, so u prime is equal to y prime. And then v is equal to 3y squared minus x. So v prime is equal to 6y y prime minus 1. So the second derivative would be equal to u prime v minus u v prime all over top of v squared. I'm going to bring up a new screen and then finish this one off. So the second derivative, so u prime is y prime times v, which is 3y squared minus x, minus u, which is y, times v prime, so 6y, y prime minus 1. This all over top of 3y squared minus x to the 2. Now, here's where we have to be careful. We can, when you're dealing with implicit differentiation, it's okay to have the y in your answer. In fact, that's often the case. But you can't have a second derivative defined in terms of the first derivative. We have to take that y prime, which we know to be y over 3y squared minus x, and we have to substitute it in for this y prime and this y prime. Now some people will do it later after they've cleaned up that numerator, and that's fine. I'm going to do it now because when I peek at it, look ahead, I see that this 3y squared minus x can cancel. So on that first cluster at least. And then the second one is 6y, y prime, so 6y times y over 3y squared minus x. And then minus 1. All over v squared, so all over 3y squared minus x to the 2. And then that does cancel, the 3y squared minus x, and we're left with just y minus, now I'm going to distribute that negative y in, so that'll give me 6y to the 3 over 3y squared minus x, and then the negative y times the negative 1 is plus 1. And then this is all over 3y squared minus x to the 2. Y plus y is equal to 2y. So 2y minus 6y cubed over 3y squared minus x, all over top of 3y squared minus x to the 2. Now the normal procedure is to, with a complex fraction like this, is to multiply to get a common denominator on top, simplify that expression, and then divide by the denominator. But you'll recall that you can also do that more quickly by multiplying by 3y squared minus x on top, and then 3y squared minus x on the bottom, which is the same thing. It's doing both those operations together, and then we'll get y double prime is equal to 2y multiplied by 3y squared minus x minus 6y cubed, because that denominator is gone, all over top of 3y squared minus x to the 2. And then when you distribute that 2y in, you'll get 6y to the 3 minus 2xy minus 6y to the 3. And this is all over 3y squared minus x to the 2. The 6y cubes will divide or subtract away, and then we get our second derivative. So d squared y over dx squared is equal to negative 2xy over top of 3y squared minus x to the 2. So that is the typical method for it. So that takes care of the second derivatives. The only lesson remaining is going to be actually no new material. There will be just a sort of a review class on some variations for practice. So thank you for your time.